Okay guys, these are the notes for if you were absent on Monday. We talked about binomial expansion, so you should pull up your notebook and your slides presentation, and then you need to get your workbook out. You want to find the examples that are for 2A.2.3. I don't know what page it is, so you're gonna have to look at the tops. I don't have an actual workbook to see. Okay, so you guys can go to slide 6. Go ahead and fill out your table of contents for me, please. Today we're going to be on slide 13 through 15. We're going to be talking about binomial expansion. You can pause here and get that typed down. Then you can get over to slide 13 for me, please. You guys are just going to type it in, so just highlight where the little blue line is, and then you can just type it in right there. Okay, so binomial expansion is a way to multiply out a binomial raised to a large exponent. So, for example, if you see x plus 3 squared, what that means is you're taking, let me get the pen, sorry. It means that you're taking x plus 3 times x plus 3. You're taking that twice, the same thing, the binomial twice, and you're multiplying it by itself. Here, we could easily use box method to multiply this out. We would just get x squared plus 6x plus 9. But what if your problem said x plus 3 to the 8th power? What that means is you have x plus 3 times itself 8 times. So you're going to type out x plus 3 8 times being multiplied. That's going to be a lot of work to multiply out x plus 3 times itself 8 times. You would actually have to do box method 7 times in order to get to your answer. That is a lot of work. Instead, what you can use is something called binomial expansion. And binomial expansion uses patterns. You guys can fit this in better than my writing, but binomial expansion uses patterns so we don't have to do box method multiple times to get an answer. All right, so over here on the right-hand side of your slide, I had to move my text box up a little bit and my picture down a little bit because a couple of your steps are actually going to need 2 lines. So just do your best. Mine's gonna look kind of messy, but yours will look nice and neat because it'll be typed. Okay, so step 1, your first step, the first thing you're going to do when you have binomial expansion, you have 3 pieces. You have a first term that's a, you have a second term that's b, and then you have an exponent that's n. How you start is you use the exponent to match Pascal's triangle row. Use exponent to match Pascal's triangle row. Here guys, this will be nice and written out. Mine's just a little bit messy. Yours will be typed. Okay, so what that means is whatever your exponent is, you go match this little Pascal's triangle right here. You go match the row. So if your exponent was a 4, a plus b to the power 4, you would go here to row 4 and you would use these 5 numbers right here. And then if you were talking about, row your exponent was an 8, you would go to row 8. So how you can tell which row it is easily is it's the second number. So if you want to row 8, you see how the second number is 8. Then that's the whole row that you would use right there. Okay? All right, step 2 is you're going to start with your exponent on a. So a is the first term. You're going to start with your exponent on a, and you're going to use the exponent on a, and then each term that you go down, you're going to decrease your exponent. So first you start with exponent on term A. I have to redo these numbers. And work in descending order for each term. Step 3, you're going to kind of do the same thing, but you're going to work backwards using b. So for the term b, you work backwards with exponent on b. descending to the left. And then after you've typed that in, you might have to, like I said, move your text box up a little bit or your picture down. The last step, step 4, is to simplify. And that word simplify can get a little lengthy, okay? All right, so what we're gonna do now is we're gonna go ahead and go to the next slide, slide 14. We just have a little bit of notes we'll take on this page. We're gonna do some examples. So binomial expansion, when the binomial, remember binomial means two terms, when the binomial has a minus sign between the two terms, the polynomial will have a plus minus pattern for the answer. You guys will see when we do an example. And something extra that you guys should know is that Pascal's triangle is it actually corresponds to the number of combinations of items possible. So what that means is if you have like this Pascal triangles, this little one right here, like this C52, what that means is if you have 5 items, you can have whatever numbers here on Pascal's triangle. If you have 5 items, that's how many combinations of 2 I could create. So say I had 5 people in my class that wanted to run for representative, and I could pick 2 of those 5 students. There's so many combinations I could make out of those 2 students. Which this is a Math 2 topic that you guys I don't think got to cover after spring break, so I know it seems kind of weird, but that. Okay, I'm gonna kind of go around like a little bit. I'm gonna move around. I'm not gonna do these examples yet. I need you guys to find the guided practice that says binomial theorem 2A.2.3. You can pause here if you need to go find it. We're going to go to example numbers 2 and 4 are the only ones we're going to do today, along with some other little examples. But example 2 says find term 4 from row 6 of Pascal's triangle. So here's how you create Pascal's triangle. You always start with a 1 on the top, and then you always increase. You have one extra number for your each one, and there's always ones on the outside. So my next row is just going to be ones on the outside, and it has 2 numbers. So my next row is going to have 3 numbers. It'll have 1 on the outsides. And then how you find the number that goes in the middle of that is you add these 2 numbers above. So you add the 1 and the 1, and you add those together and get 2. So I'm trying to find row 6. I'll know I'm at row 6 when the 6 is my second number. So I put 1s on the outside. And then I add the 2 numbers 1 and 2 and get 3. And then I add 2 and 1 and get 3. And then I put 1s on the outside, and then I add my 1 and my 3 and get 4. I add my 3 and 3 to get 6. I add 3 and 1 to get 4. I'm not at row 6 yet. I'll know I'm there when I have a 6 as my second number. All right, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then I'm finally at row 6. I know because my second number is 6. 5 plus 10 is 15. 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6. So the question asks, it says find term 4 of row 6. So I have row 6 right here, and I find term 4. 1, 2, 3, 4. The 4th number is 20, and that's my answer. That's all it wanted for example number 2. Example number 3 says Kamali has 7 unique bracelets, is trying to decide which 3 to wear on a date. Use Pascal's triangle to find the number of different combinations of 3 bracelets that Kamali can choose from the 7 that she owns. So this is 7 choose 3. This is something that, like I said, it's a Math 2 standard. We don't cover it in Math 3. Maybe later on if we have time. It's one of those topics that you probably missed because of distance learning. Okay, so what you have to do is you have to get Pascal's triangle, row 7, term 3. So we already have Pascal's triangle up here for row 6, but we need row 7. So I'm just going to kind of go up to the example number 2, and I'm just going to figure out what row 7 would be. You would have a 1 on the outside, remember? And then you would fill it in by adding 1 and 6 gets 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35 again. 15 plus 6 is 21. 6 plus 1 is 7. So this is row 7 of Pascal's triangle. I just used the triangle up in example 2 and came up with my numbers. So we have row 7, term 3. I lied, it's not term 3. It's row 7. It's actually going to be term 4, because if you saw over here on this little, sorry, I have to scroll back. You actually start with, on the outside is 5, choose 0, like on this line right here. And then it says 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. You actually start with 5, choose 0, and then the end is 5, choose 5. So on ours, this one right here is actually 7, choose 0, 7, choose 1, 7, choose 2. This fourth one is actually 7, choose 3. So there's 35 different combinations of bracelets that she could wear on her date. So again, use Pascal's triangle of row 7. It's not term 3. I was mistaken. I'm sorry, because it starts off with 7, choose 0. There's one way to choose no items. You just don't choose any. If she wanted to wear one bracelet, she had 7 different options of what she could wear. If she was going to wear 2 bracelets, there's 21 different combinations she could use. And if she wanted to wear 3 bracelets, there's 35 combinations. All right, let's get to the fun stuff. Let's actually do some binomial expansion problems using these steps that we wrote down right here. Use exponent to match Pascal's triangle row. Start with exponent on term A, work in descending order, work backwards, and you guys can see what I mean by those, okay? So we're gonna do our first example of n plus d to the power of 7. So you guys are just gonna write this on a separate sheet of paper, and eventually you're gonna put it onto slide 14. All right, so here, the n is like our term A, d is our term B, and then 7 is our exponent. So the first thing we're going to do is go to Pascal's triangle. We're going to go to row 7. Okay, that's what our steps say, is to first go to Pascal's triangle to match our row. Can't get this to stop. Okay, I don't need that. So I'm going to start with my exponent. My exponent is 7. My Pascal's triangle row, the numbers, remember, were 7, 1, 7. Notice I'm going to leave like some space in between them. And you have Pascal's triangle in your little notes, but we did just do this one. 21, 35, 35, 21, 7, and 1. So notice how I left a bunch of space kind of in between them. All right, the next step is to take your first term, which is n, and you're going to raise it to the power of 7. So you start with your n to the power of 7, and as you work your way down, you decrease your exponent. So n to the power of 6, n to the power of 5, n to the power of 4, n to the power of 3, n to the power of 2, n to the power of 1, and then this last guy is n to the power of 0. It doesn't get any. Then I'm going to work backwards with my letter D. Okay, I'm going to go to the very end, and I'm going to start with d to the power of 7 on that very last one we had, and then I'm going to work in descending order going the opposite way. N to the power of d to the power of 6, d to the power of 5, d to the power of 4, d cubed, d squared, d to the power of 1. So some things you should notice is that your exponents always add up to 7. 7, 6 plus 1 is 7, 5 plus 2 is 7, 4 plus 3, 3 plus 4, 2 plus 5, 1 plus 6, and 7. Our simplifying is our last step, and to simplify, we're just going to go ahead and put plus signs pretty much between our terms. So 1n to the 7th, we don't actually have to write the 1, it's just n to the power of 7, plus 7n to the power of 6, d, we don't actually have to write the power of 1, plus 21n to the power of 5, d squared, plus 35n to the 4th, d cubed, plus 35n cubed, d to the 4th, plus 21n squared, d to the 5th, plus 7n d to the 6th, plus d to the 7th. I kind of ran out of room there. And that's my answer. So Pascal's triangle, instead of having to do box method 6 times to get this one answer, we can use this little pattern. Okay, we're going to do a couple more examples so you guys can kind of see the pattern. So first step is to use your exponent with Pascal's triangle row. So Pascal's triangle is on one of the slides slide 13, I think it is. So you go to where the row has the second number of a 4. So those numbers are 1, 4, 6, 4, 1. All right, then you take your first term, which is x, and you start it with the exponent of 4 at the first term, x to the power of 4, and as you work down, you decrease x to the power of 3, x squared, x to the power of 1, and then the last one doesn't get any x's. Then you're going to work your way backwards with your part B, 3. So at the very last term, I have 3 to the power of 4, and I'm going to work my way down. 3 to the power of 3, 3 to the power of 2, 3 to the power of 1. All right, so here when we simplify, we have a little bit more work than we did in our last problem, okay? So the first term is 1x to the 4th, so it's just x to the 4th. But now I actually do have some numbers to multiply. 4 times 3 gives me a 12x cubed. 3 squared is 9, so 9 times 6, what is that? 54 x squared. Over here we have 3 cubed, which is 27, so I have 4 times 27, so this one is plus 108x. And then this last one is just 1 times 3 to the 4th, which is 81, so it's just plus 81. And then that would be my final answer. So the difference between number 1 and number 2 is that number 1, both of the terms were variables, so there wasn't anything really to simplify. But with example number 2, one of our terms was a constant, the number 3, so we were actually able to raise 3 squared, 3 cubed, 3 to the 4th, and multiply with those Pascal's triangle numbers that were in front. All right, one last example, and then you guys are going to do some practice for your homework tonight. Okay. So this one says m minus 1 raised to the power of 5. So you start with Pascal's triangle, the number 5, row 5. So those numbers are 1, 5, 10, 10, 5, 1. Then I start with my first term is the letter m, and we're going to raise it to the power of 5, m to the power of 5, m to the power of 4, m to the power of 3, m to the power of 2, m to the power of 1, and then the last one doesn't get an m. Then we're going to work with our second term, which notice how all the other problems I didn't actually take the sign with it, but this one has a negative in between. So I am going to use that negative sign. So on the end it's going to be negative 1 to the power of 5, negative 1 to the power of 4, negative 1 to the power of 3, negative 1 squared, and negative 1. All right, so you guys are going to see what happens when we have a negative in between our binomial, that minus in between the m and the 1. So my first one is just 1m to the 5th, so that just stays m to the 5th. Now we're multiplying 5 times negative 1, so it actually becomes a minus 5m to the 4th. Here we have negative 1 squared, that comes first. So negative 1 times negative 1 is actually positive 1, so 1 times 10 is actually positive 10. M cubed. So see how the first term is positive, the next one's negative, then it goes positive. And then here you have negative 1 cubed. Well, negative 1 times negative 1 times negative 1 is negative 1. So 10 times negative 1 is negative 10, and then you have m squared. And then negative 1 to the 4th, negative 1 times negative 1 times negative 1 times negative 1. If the exponent's even, it actually turns to a positive. So 5 times 1 is plus 5m. And then lastly, we just have 1 times negative 1 to the 5th, which is going to be a negative 1. So notice how the pattern goes. Positive term, negative, positive, negative, positive, negative. And that's our final answer. So for homework, you guys are going to do a little bit of practice and finish your notes. Okay, so you're going to have a little bit of practice of you guys trying to do this and a little bit of notes to complete as well. Okay?